Okay, that was a weird thing that happened. All right. I was trying to start the recording early, but then they kicked me out. And then it's like, oh, now we're starting the recording. I'm like, all right, cool, I guess. Anyways, review session time. So, before we start, a few quick things. So, exam 1 starts tomorrow at 9 a.m. and you have until this Sunday at 9 a.m. to take the 60-minute exam. Covers lessons 2 through 10. And like I said last time, please make sure you have a place with stable enough internet so that way you don't have to worry about any weird connectivity issues during the exam. And then one thing I'd recommend is make sure you get good enough practice beforehand before you take the exam. I know you can technically access notes and whatnot. Like, it's open note, you can check your notes and all that, but I'd recommend just doing practice beforehand without the notes, just so that way you're not like flipping between like 1,200 pages of notes during the exam. You're like, well, then you lose a lot more time than you think. So, okay. And one thing I probably should have mentioned, but I haven't yet, so at least not in person, is that no class on Friday to compensate for the exam. Okay? And I will also have a Zoom office hour, or 2 office hours rather, from 6 to 8 tonight for any last minute questions you may have. So, because once the exam window opens up tomorrow, I am not going to answer any questions, period. Unless it's like trying to connect to the internet or something. Because if it's anything like exam related, like, okay, how do I do this? I'm like, well, you guys are on your own, because I don't know, because I haven't looked at the entire exam yet. So I don't know what exactly is going to be on there beyond stuff from these lessons. So just make sure you guys are familiar enough with the material beforehand. So yeah, okay. Yeah. So basically during this window, I will not answer any questions as long as the exam's up. So okay. Any other questions on any of that? Okay. So with that out of the way. This is the exam 1 review session, so basically it's going to be centered around you guys this time. So basically if you have any questions, anything you guys want to talk about, I'm all ears. Go ahead and ask me any questions you may have for the exam. So I'll give you guys a second to see if there's any pressing questions that you guys would like to look at. So any question you guys would like to look at, or anything from the practice problem packet?
Could you go over number 5 from the practice packet?
Sure. Let's say. Number 5. Okay. That's a good one. So. Okay. So the premise is, all right, so the population P in thousands of a small city is given by P of T equals 50T over T squared plus 9, where T is the time in years. So the goal is we're trying to find the rate of change of the population at T equals 2 years to the rounded to the third decimal place. Okay? So if you recall, if we're asked to find the rate of change of the population, and we're given the population in terms of t here, then what should that tell you about what we need to find?
Like, what do you find the derivative?
Yeah, you find the derivative and then plug into it, right? So find p prime at 2. Basically is all the question's asking you to do here. Okay? So if that's the case, we say, all right, well, we should probably figure out what the derivative itself is first. So if p of t equals 10 plus 50t over 2t squared plus 9. Okay. All right. So let's take a look at the derivative. So the prime of t, well, we have 10, so derivative of 10 is big fat 0, so we can just ignore that. So ultimately, the derivative, the function of the derivative is ultimately going to fall to what this is going to become. So if we differentiate this, then, well, we have one function of, in this case, t divided by another, so that should pretty quickly tell you we need to use which differentiation rule?
The quotient.
Quotient rule, right. So in this case, if we were to use the notation from quotient rule, then we have, well, 50t, and g of t would be the denominator, so 2t squared plus 9. So that's the case. Well, if we remember the quotient rule here, then we also need to have the derivatives as well. So let's find them before we get too far into computing the derivative. So the corresponding derivatives of f and g are going to be what here?
50 and 40.
Yep, 50 and 4t. Okay, so that's just a quick application of power rule. And we have these functions given to us, and that means p prime of t should then equal what here? So what does quotient rule tell us here? So I guess first things first. So if we take our function straight from this red box and plug them straight into quotient rule, what should we immediately get? Quite read that. All right. So remember, what quotient rule says is that the derivative of p prime should then be, well, g of t times f prime of t. So low d high minus high, so f of t times g prime of t all over g of t quantity squared. So if we plug all this in, we should have, well, so g of t is 2t squared plus 9 times f prime, so 50, minus f of t, so 50, times g prime, so 4t. And then all that divided by g of t, so 2t squared, 1e squared. Okay? So this in total is going to be your derivative here. So now all we need to do is just let t equal 2 here. So in this case, this is where your calculators will need to come into play here. So we have p of prime of 2. So if you let t equal 2 straight into here, then we should get what? A second. Where did you get your... So if we let t equal 2 in here, what should we get as our decimal approximation here? Go ahead. Or did you? Or are you having a raise? Are you raising?
Well, my calculator said 1.557, but that's not an answer choice. The only one is negative 1.5. So I'm guessing it's something.
Yeah, I think there's a bit of an issue. So in this case, if you let t equal 2 in here, we're just going to end up with, well, you should end up with, this is your final answer here. This is this choice C. What you should end up with if you let t equal 2 in here. So, okay. Any questions on that? Yeah?
I just have a separate question.
Sure, what's up?
Could I ask you a question from a quiz?
Sure. Which quiz is it from, though? I should probably ask.
Quiz number 2.
Okay, well. Thankfully, I actually wrote that quiz, so I actually kind of know at least somewhat. So what's your question?
It says that you were told that the derivative of f of x is a secant of x. So, and then it's like the f derivative of x
Yep.
is a secant x times tangent of x. And then it says using the limit test and expensive derivative, which of the following equals the derivative?
Yep, I remember that one. Yes, I do. All right, so given the derivative of, let's say f of x equals 5 times secant of x, is f prime of x equals 5 times secant of x times tangent of x. Okay, I need to zoom that out. I was not watching that carefully. My bad. Okay, so we're given that the derivative of 5 times secant of x is 5 secant tangent, right? This says that using limit definition of derivative, that 5 secant of x times tangent of x equals what? Okay. So we're given that f equals 5 times secant of x has derivative 5 times secant times tangent. So we need to use the limit definition of the derivative to express this in a different way. This 5 times secant times tangent. So if you recall, well, we should probably first figure out, well, what's the limit definition say? So, if you recall, well, f prime of x, using the limit definition of the derivative equals what? You guys remember from lesson 6?
Is it x plus h squared? That one?
Kind of. You actually, h is going to be involved somewhere, but
Is it, f of x plus h
Yep.
minus f of x?
yep, f of x plus h minus f of x.
And then, is it all over f of x?
Not quite.
F of x.
H.
Oh,
And then because we have to use the limit definition, that means that what needs to go here?
well, that is h.
Limit as h goes to 0. Correct. Okay? So what that says is that, all right, well, okay, so let's zoom in on that. So if that's the case, that says, all right, well, we should probably identify f prime, f of x plus h, and f of x. So the good news is that f of x and f prime of x are already given to us in the problem. So f of x is just 5 times secant of x, and then f prime is secant of x times tangent of x, right? So then what does that tell us about what f of x plus h is in that case? So if f of x equals 5 times secant of x, then f of x plus h is just what?
Is it 5 secant of x plus h?
Right. Secant of x plus h. Because remember, all we're doing here is just replace x with x plus h. Okay? So that's all we're doing here with this step from here to here. Okay? So if that's the case, all we have to do now is just put everything in the limit definition to get that. Well, 5 times secant of x times tangent of x equals, well, the limits as h approaches 0 of, well, f of x plus h, so 5 times secant of x plus h, minus f of x, which is 5 times secant of x, all over h. Okay? So that would be your answer here. Okay? So, any questions on that?
Do the differentiation basics, are they also applicable here, or what do you only use the limit definition for these types of problems?
So in this case, if you're asked to use the limit definition of the derivative, then basically make sure you know this. The caveat is that you technically would not be, I don't know of a good clean way to be able to find the derivative of secant using the limit definition, but we have the derivatives of sine and cosine, and we already figured out how to find the derivative of secant from last time, right? So that's one way you can find the derivative of secant, but I'm just doing this here just so you guys have a conceptual way of understanding what the limit definition says. Because we did a similar example, I think, in lesson 6, except we had f of x equals sine and f prime is cosine. So, okay. Okay. So any questions on that? Okay. So any other questions you guys want to look at?
Can you go over number 12 on the
Sure. Number 12. What did that one say? So number 12. Aha, this is a good one. So, does anyone still need this? So, number 12. So we're given this okay, hold on. Okay. Alright. Camera, please. Alright, alright. Autofocus, thank you. Focus, thank you so much. Alright. So we're given this piecewise function, f of x equals x plus 4 if x is less than or equal to 2, negative x minus 2 if negative 2 is less than x and less than or equal to 2, and x minus 2 if x is greater than 2. So now we're trying to figure out which of these following statements is false. So make sure to keep that in mind when you're looking at these types of problems. So we're trying to figure out which of these is not true. So basically, what we're sort of looking at here is we're taking a look at basically the one-sided limits around, well, in this case, not only plus and positive and negative and positive 2, but also 0. So basically, let's take a look at each of those. So all we're really doing here is we just have to find the limits as x approaches 0 from the right of f of x. The limits as x approaches, well, in this case, just going in order of the problem statements. 2 from the left, limits x approaches 0 from the left of f of x. The limits as x approaches negative 2 from the left of f of x. Limits x approaches negative 2 from the right of f of x. And then the limits as x approaches 2 from the right of f of x. Okay? So in this case, well, let's start by just going down the row. So if we take a look at the limit as x approaches 0 from the right of f of x, that means that what? So if you recall, this 0 with a positive superscript here indicates that we have to look at values of x that are slightly greater than x equals 0. So which of these three pieces of f of x will allow us to work with that? Yeah, second one, right? So limit as x approaches 0 from the right of, well, let's see, it's the middle one, so negative x minus 2. So in this case, well, this is just a function that's continuous everywhere, so in this case we can just let x equal 0 right away to get that the limit is going to be negative 2, right? Because in this case, well, we can just let x equal 0 right away here. So now let's do the same thing with the limit as x approaches 2 from the left. So in this case, if we want to focus on values of x that are slightly less than 2, then which of the three pieces of f of x should we use here?
The top one.
The top one? We're focusing on values of x slightly less than 2.
Less than 2, the middle.
Middle one, right. Because if we were focusing on values that were slightly less than negative 2, then yeah, I'd agree with you. But in this case, we are focusing on positive 2 here. So in this case, we have negative x minus 2. So the limit value of that is going to end up being what? Negative 4. Except, oh, wait a minute. We're trying to figure out which of the following statements is false. So that should automatically tell you that since, well, this is not negative 2, so that should tell you that, in this case, B will be your answer here. Okay? So, and again, you can keep going down the line until you exhaust all the options, but in this case, you only need to see that. In this case, you only need to see that the second choice is wrong, so that'll be your answer.
Does negative symbol matter in the limit? Because I think there's 1 after the 2. Does that matter at all?
This one?
Oh no, in the, like, in answer choice B, like, you see how there's a negative sign after the 2, does that, like, really matter?
Well, that just indicates you're approaching 2 from the left.
Oh,
Yeah, so remember, with one-sided limits, you have like those positive and negative superscripts. So this negative one indicates you're going from approaching 2 from the left, but a positive superscript will indicate you're approaching the value from the right. So if you want a pictorial version of that, then if you have C here, then this would be x approaches C from the left, and then x approaches C from the right, with x less than C and x greater than C. So if you want like a pictorial version of that, then that would be it. Okay, any other questions on that? Okay, does anyone have any other questions they want to look at? Okay, so there's one more topic what? Okay, I was like, couldn't tell what was happening here. But all right, so okay, because there's one more thing I wanted to look at, and basically it's sort of follows up from this question here. So it's basically focusing on discontinuity. So if you recall, let's just do this. Start with a fresh new page here. All right. So we're just going to go and do a quick refresher on continuity because I'm pretty sure that's going to be pretty important on the exam. So just doing a quick refresher on continuity. Okay. The first thing we're going to look at is, well, what's the definition of continuity? So without looking at your notes, just see if you can remember off the top of your heads. Continuous. So f of x is continuous at x equals c if 3 criteria hold. If I can count, that is. There we go. Okay. So remember, so f of x is continuous at x equals c if 3 criteria are fulfilled. So what does anyone remember what those 3 criteria are?
I remember one of them, but if the one-sided limits exist and are the same.
Right. So yeah, that counts. So the two-sided limit of f of x exists, right?
Yeah.
Okay. So that is one of them.
There's one of them, like the f of x has to equal f of c.
Yeah. The limit. So yeah. So basically, the most important one you need to remember is that the limit as x approaches c of f of x is f of c. And then, of course, that would sort of implicitly mean that this has to be defined here. So f of c is defined. But like I've been stressing when we talked about continuity, the idea is that this is basically the most important one you need to focus on. So basically what I'm saying is that like if you forget these two, well, you kind of shouldn't, but it's okay, because the thing is that basically the most important thing is that as long as you remember this, that's like the big key thing here. So most important. Okay. So now that we have that taken care of, let's take a look at the types of discontinuity from this. So discontinuity types. Okay? So if you recall, there were 3 types of ways we could have a discontinuity. Does anyone remember what they were?
Whole, jump, and vertical asymptote.
Yep, whole, jump, and vertical asymptotes. Good. Okay. Okay, so let's briefly talk about what those were. So with a whole, there were 2 criteria that needed to be fulfilled. So the two-sided limits, as x approaches c, of f of x exists and is finite, so this my criteria 2 here is fulfilled, so that's all fine and dandy. But then criteria 3 is broken. So the limit as x approaches c of f of x just does not agree with f of c for whatever reason. And this could be because f of c is straight up undefined, so that's the first way. The second way is that f of c is defined, but they're just not equal to each other. So in a graphical way, you could have something like this happen. So the two one-sided limits go to the same y value, but they cannot approach the function value, and that could be either because the function value is undefined, or it is defined, but it's just f of c is somewhere else. So if you remember, this filled in dot here would indicate f of the function value at c here. So, alright, so that would be the first type of discontinuity. Second type is where we have that the one-sided limits existed and are finite. F of x, limit x approaches c from the right of f of x, exists and are finite. So that checks out fine. So the one-sided limits are good to go. But the limit as x approaches c of f of x does not exist. Okay. Now, if you recall, if the two-sided limit does not exist, what did that mean about what the one-sided limits satisfied? So this two-sided limit does not exist if the one-sided limits were what?
If they weren't the same.
Yeah. So in this case, so one-sided limits do not equal. Okay. So that's that one. And then just to give you an idea of what that would graphically look like, it's going to give you something like this. And the nice thing with at least a jump, we don't really care about what's happening with the function value at c. It could be defined, it could not be. The function value could be one of these one-sided limits. It could be somewhere else entirely, but at the very least, you're going to have something that looks like this. So, like I said, f of c could be here, it could be here, it could be literally anywhere, or it could just be nowhere at all. But for a jump, all we care about are the one-sided limits, essentially. And one thing to keep in mind is that this can only happen for piecewise functions. Piecewise functions only. Okay. So that's jump. A vertical asymptote, what that says is that the function value is undefined, but the one-sided limits are plus or minus infinity. F of x, and then limit x approaches c from the right of f of x are plus or minus infinity. Okay? So in this case, what you could end up with, graphically speaking, are just as a couple of quick examples. You could have something like this, or you could have something like this, where in this case, one of the one-sided limits shoots up to positive infinity, the other shoots down to negative infinity, and then in this particular case, both of the one-sided limits would approach the same asymptotic behavior. So in this case, they would approach positive infinity. But you could also have the case where both of these shoot down to negative infinity. Okay. All right. So, with that in mind, let's take a look at two examples that we're just going to pull straight from lesson 5. So let's harken back to that. Okay. Okay. All right. All right. So example 1, or I'll just say example here because this is basically the last thing we'll do for today. So find where f of x is discontinuous and classify discontinuities. Okay? So the first one we're going to look at is, like I said, we're just going to pull straight from lesson 5 here. So we have f of x equals what? So x squared plus 3x minus 4 divided by x squared plus 4x minus 5. Okay? Now, if you recall, so in this case, we have one quadratic function over another. So in this case, if we take a look at f of x here, so the only way we can get any type of discontinuity here is if the function is undefined at a particular value of x. So in the case of a rational function, so when do we get that the function, a rational function, is undefined? What's the only way that can happen? Right. So rational function is undefined when denominator equals 0. So if that's the case, set denominator equal to 0 to get discontinuities. Okay? So if we set this denominator equal to 0, well, because we have a quadratic here, that should mean that there are, in this case, going to be two values of x which we have an undefined behavior. So what would those two be here? So x equals what two values? What two values of x do we get here?
5 and -1.
Yeah, just 5 and -1, right? Because in this case, well, the denominator is just going to be, what's this? So what do we have? Okay, so yeah, x plus 5 and x minus 1. So that's how you can factor the denominator here. All right. So in this case, these would be the two values of x in which we have a discontinuity. So now let's classify these. Okay. So before we do that, though, let's simplify f of x first. X first. So that'll help us classify discontinuities a bit easier. So in this case, we already have the factorization of the denominator. So we have x plus 5, x minus 1. So now let's do the same thing with the numerator. So what would the factorization of that be?
Isn't it x minus 5, x plus 1?
Oh, yep, right. Wait, huh? Yep. Yeah, yep, okay, yep. You're right, yeah, plus 5, hang on a second. No, it's plus 5 minus 1. I was like, wait a second, double checking my notes, like, wait a second, it's...
No, because then when you look at the discontinuity, 0, 5, and -1.
That's where, okay, yep, that's where things are not lining up. Okay, my bad. I was like, okay, so plus 5 minus 1. Okay. All right, sorry about that. Okay, Okay, so now we have that figured out. So what does the numerator simple factor as? X plus 4, x minus 1. So in this case, well, the nice thing is that on our domain, i.e. x is not equal to -5 or +1, these x plus 1 factors cancel each other out fairly nicely. So we have the simplified version of f of x becomes x plus 4 divided by x plus 5. So now, we say, all right, if we focus on x equals +1 first, okay, then let's look at the limit value as x approaches 1. So the thing is that if we just focus on f of x as we had before, then the limit as x approaches 1, well, since x minus 1 is a factor of both of these quadratics, well, we're going to get 0 over 0, right? But thankfully, that's where our simplified version of f of x comes into play here, because once we get rid of those x minus 1 factors, we can say that the limit as x approaches 1 of f of x can also equal the limit as x approaches 1 of its simplified form. So in this case, if we just let x equal 1 here, well, the good news is that we just get a nice finite number out of this, right? So then, if that's the case, then that means our limit here is going to be what? 5 over 6, right? So what does that tell you about the type of discontinuity we have at x equals 1? It's a hole, right? And why is it a hole? So the limit itself exists and it's finite, but, well, the function value is undefined, right? So we get a hole there. So now let's do the same thing with -5. So if we approach -5, well, we can still use the simplified form, and that's okay. But so there's a tiny little problem though. What happens if we let x equals -5 straight into here?
-0.
Right. And specifically, what happens on the numerator? So we get something 0 divided by 0, but what's that something here? -1, right? Or just some non-zero number, right? Non-zero number divided by 0. So if that's the case, that says, all right, well, if you recall from lesson 4, that's what we denote as a case 2 limit. From lesson 4. And do you remember what we said about case 2 limits? So what we said was that the one-sided limits were what? What did we say about the one-sided limits in that particular case? You guys can look at your notes if you forgot. Right. They're plus or minus infinity, right? So we have that the one-sided limits are plus or minus infinity, and f of -5 is undefined. So that means we have what type of discontinuity here? Bingo. Vertical asymptotes. X equals -5. Okay, cool. Cool. So, any questions on that? Alright, so I don't think we're going to have enough time to be able to do another examples, but I could probably answer one more quick question if you guys have one.
Is it asking me like all multiple choice problems that you studied?
I would say part of them could be, part of them could not be. I haven't seen the whole exam, and in this case, since it's all online, I imagine it's going to be like the quizzes where, some of them are multiple choice, some of them are not. Okay. Okay. Any other questions you guys want to take a quick look at? Yeah?
How many questions is this?
I think 12-ish is probably my guess. I think, yeah. But
There's only 12 questions in that one.
yeah, there's like 12, sort of, essentially like 12 questions, essentially. They may have individual subparts, but they should be pretty quick. Kind of like lesson 3, for example. Okay. But like I said, I have office starts tonight from 6 to 8. If you guys have any questions that you guys would like me to answer before the exam window opens up. Otherwise, I will see you guys on Monday, and good luck on the exam. Yep.
Just a quick question on this. It says a student use a limit process to find the derivative of this. So I'm assuming we use quotient rule because it's a fraction 1 divided by another.
Oh, yeah, sorry. Let me stop the recording.